Hi everybody, I just wanted to walk through some of the sort of calculations and some of the material from Module 1.1 in preparation for any time that you see this in the future, be it 1.12 or when you take the final exam. So if you would please just go ahead and watch this for a nice little review. Alright, so the first thing that I wanted to get after was an example problem. And this is very similar to the first problem that you saw in your 1.1 assessment. And this question presents a copper atom with 31 neutrons and a +3 charge. Now, what I want to draw your attention to is this right here that I'm highlighting in red. This symbol is from the periodic table. This is just a screen capture from the periodic table. And I want to draw your attention to some of the numbers on it. The first number is this 29. Then below that we see the symbol Cu, the name copper, and then 63.546. So what this is telling us, we're dealing with an atom. This atom specifically has 31 neutrons, and ultimately it has a +3 charge. Now, those number of neutrons are significant, but before we tackle that, let's go ahead and look at our information that we're asked for. We are asked for the atomic number. The atomic number is a number that comes directly from the periodic table. Now, for copper, the atomic number is 29. Which means that copper has 29 protons. There are no other atoms that have exactly 29 protons, because if you make an atom with 29 protons, no matter how many neutrons or electrons, you are talking about copper. So the atomic number for copper is 29. So I will highlight that there. The next number is your mass number. Okay, so your mass number is going to be the number of protons plus neutrons. Now, even though we have the 63.546, that is not necessarily your mass number. This is telling us we are talking about one specific atom that has 31 neutrons and 29 protons. So our protons, 29 plus 31 neutrons equals 60. So our mass number for this specific atom that this question is asking us about is 60. Okay, the next question is number of electrons. Okay, so generally when you talk about an atom, a neutral atom, let me write that out, neutral atom, you have atom, protons, proton number is equal to electron number. Now, in this case, we have a non-neutral atom. This atom has a charge of +3. So what does that mean? Well, protons, 29 positive charges. We know that much. Now, how are we going to figure out our number of electrons? Well, you can take the proton number and subtract from it the electron number. And then get your charge. So this is a little bit of simple algebra. 29 minus blank equals +3. Okay, so what do we do there? Well, one thing that we'll do is we'll add our blank to the other side, subtract 3. So you can put the electron number as x, add x to each side, so 29 equals 3 plus x minus 3. I know I kind of jumped a step there. Minus 3 equals 26. So x is our number of electrons, which is 26. Okay, so we have a total number of 26 electrons here. Now, this full chemical symbol, the last prompt that we're provided with, what that is asking us to do is basically reconstitute all of this and present all this information in a similar way. Well, the first thing that you need to worry about is your symbol itself, which is Cu, the letters. Now, what you'll do after this is you'll fill in the blanks on what's around this symbol. Upper left-hand corner, upper right-hand corner, and your lower left-hand corner. Okay, so your lower left, or let's start with your upper right-hand corner. That's where you're going to indicate a charge. This specific atom has a charge of +3. In the upper left-hand corner, you're going to include your mass number, which for us it's 60, and then in the lower left-hand corner, that's going to be our number of protons, which is 29. I hope that was helpful for this problem. Now we're going to proceed onward. So the next part of dealing with any sort of atom and understanding an atom is looking at more than just a single atom. And for that, we need to consider our average atomic mass. Okay, so the number that you see on the periodic table, well, one of them is your atomic number, ATOM number, but then the other number is going to be the mass. Now, what is significant about this is when it comes to writing 63.546, what you need to know and what you need to be aware of is the difference in units that you choose to use. If you write AMU, AMU stands for atomic mass units. So 63.546 AMU is the mass, or sorry, is the, let me see if my eraser works for this thing. Booyah! This is our average mass of one copper atom. Okay, so if you write 63.546 grams, that is the mass of 1 mole of Cu atoms. Now there's a little bit to unpack there. 1 mole of Cu atoms. What does that mean? Well, that means 1 mole of Cu atoms is 6.02 times 10 to the 23rd Cu atoms. So that's a ton of atoms. So 63.546 grams is not a huge amount of mass if you consider 454 grams is 1 pound. So this is getting at 63.546 grams of copper atoms. If you had that, you could put that in your hand. That would mean you would have 1 mole of copper atoms. Okay, now this average atomic mass, what does that mean? Well, what that means is that there are a number of different entities known as isotopes. And those are different forms of copper atoms. So different forms and atoms altogether. So different forms of the same atom. So for copper, let me pull this up on the periodic table. Okay. Copper has a number of different isotopes. Copper, as an example, has a total of 4 different isotopes. So copper has 63 Cu, 64 Cu, 65 Cu, and 67 Cu. Those are all of the 4 different isotopes. Now, when it comes of copper, I'm sorry. When it comes to calculating this average atomic mass, well, what that means is you are taking into consideration the abundance of all of these different isotopes. Of all of the copper atoms in the known universe, approximately 69.15% have a mass number of 63. Approximately 30.85% have a mass of 65. Now, these other two, 64 and 67, those are synthetic, and so those are not naturally occurring isotopes. So if you think about this, I try to break things down into smaller or more manageable numbers. If we had 10,000 copper atoms, 6,915 would have a mass of 63 AMU. 3,085 would have a mass of 65 AMU. Now this is very significant because what this is showing is the masses of all of the different copper atoms. Now one thing that I would like you to look at is this average atomic mass, the 63.546, that is an average of them. So the way I think about it is you have two different pools. In one pool, there are copper atoms with a mass of 63, and in the other pool, there are copper atoms with a mass of 65. Now my question is, how many of them have a mass of 63.546? The answer to that is 0. Not a single one of those copper atoms has a mass of 63.546. 69% of them, effectively, have a mass of 63, and 31% of them have a mass of 65. None of them have a mass of 63.546. That's simply an average of those two. Well, I hope that this explanation was helpful. Now we're going to go on and do a comparison of moles and masses. Okay, so here we're looking at two different atoms, nitrogen and argon. Now, if you have 14.007 grams of nitrogen atoms, you have 1 mole of nitrogen atoms. If you have 39.948 grams of argon atoms, you have 1 mole of AR atoms. Okay, so now let's look at these masses. Well, 14 grams is less than 39 grams. Let's say you had 14.007 grams of argon atoms. I like to look at this and compare that to my molar mass. So if I have 1 mole of argon atoms, I have a mass that amounts to 39.948 grams. 14.007 grams of argon atoms, that means I have a lower mass. So I have less argon, or I'm sorry, I have a lower mass, so I have fewer argon atoms. So my question is, do I have 1 mole of AR atoms? More than 1 mole? Of argon, or less than 1 mole of argon atoms? Well, when we look at this, you can say my definition is 39.948 grams of argon atoms is equal to 1 mole of argon atoms, or 6.02 times 10 to the 23rd argon atoms. I only have 14.007 grams of argon atoms. So do I have 1 mole of argon atoms? No, I don't, because if I had 1 mole of argon atoms, it would have a mass of 39.948. So I can cross that off the table. Okay. My next option is I have more than 1 mole of argon atoms. Well, 1 mole of argon atoms, by definition, has a mass of 39.948. My number of grams of argon atoms is lower than that. So I do not have more than 1 mole of argon atoms. So ultimately, what you need to do is, whenever you're given a definition like this, or these two definitions, if you have 14.007 grams of argon atoms, you have less than 1 mole of argon atoms. All right, well, that's what I got. I hope this was helpful. If you have any questions, please feel free to email me, and we can either set up a time to meet, or we can just discuss it through email. Other than that, I hope you have a wonderful day.